All right, let's dive in. Today, we're going to crack open a really fundamental piece of Bitcoin's security. We're talking about the digital lock that makes sure only you can get to your funds. So, let's get right to it.
I mean, it's the big question, right? You've got this money that doesn't physically exist. There's no vault, no security guards. So how in the world does Bitcoin make sure that you, and only you, can spend it? Well, the answer isn't about, just moving some files around. It's actually all about solving a very, very specific kind of puzzle.
And to really get our heads around this, we're going to use one main idea throughout this whole explainer. Think of every little bit of Bitcoin as being locked away inside its very own digital puzzle box.
And that right there, that's the core idea. If you want to spend your Bitcoin, you have to show up with the correct solution that unlocks that specific box. So really, the security of the entire system boils down to just two things. What are the rules of the puzzle, and how unique is the solution?
Okay, so first up, let's talk about the rules. You can imagine that every single one of these puzzle boxes has a set of conditions kind of written right on the lid that you have to meet. In the world of Bitcoin, these rules are defined in something called an output script.
So here's the key takeaway. The output script is the lock. That's it. It's just a small bit of code that lays out the conditions for spending the Bitcoin. For a totally normal, everyday Bitcoin transaction, that condition is pretty straightforward. Prove you have the secret key. Now, this is where things get really interesting, because there's a big difference between what's theoretically possible and what actually happens in practice. You see, the Bitcoin protocol could, in theory, let you create these massive, super complex scripts, but the network itself says, whoa, hold on, and it enforces a much smaller practical limit, 10,000 bytes. And there's a good reason for this. It keeps the whole system running smoothly and helps shut down certain kinds of attacks on the network. Okay, so this leads to a pretty wild question. What if a puzzle box had, well, no rules at all? It sounds crazy insecure, right? But it turns out this is a surprisingly important tool, especially for developers working on the protocol.
Yep, you heard that right. The core rules of Bitcoin, the consensus rules, they actually allow for an output script to be totally empty. A puzzle with no lock. So, what happens then?
Well, that creates what developers call an anyone can spend output. And yeah, it's exactly what it sounds like. Literally, anyone who finds it can spend the Bitcoin. Now, obviously, you would never ever use this for your own money. But it serves this really clever purpose when it comes to upgrading the Bitcoin protocol. And here's how that clever trick works. Developers can take one of these old, seemingly useless, unsecured script types, and then, using something called a soft fork, which is just a fancy term for an upgrade that doesn't break older versions of the software, they add new rules to it. And just like that, what was a featureless script suddenly becomes a brand new, totally secure feature. It's a genius way to let the network evolve without causing a massive breakdown.
All right, so we've talked all about the puzzle box and its rules. That's the output script. Now, let's flip over to the other side of the coin, the solution, the thing you provide to actually unlock the box. And this solution has a name. It's called the witness.
To really get why it's called that, let's just think about the real world for a second. You know, in a courtroom, a witness gets up and provides testimony to prove a fact. They're giving evidence, right?
The idea is pretty similar in math, just a lot simpler. If you have an equation like x plus 2 equals 4, the witness that proves it's true is just the number 2. It's that one little piece of data that makes the whole thing work.
And that brings us right back to Bitcoin. The witness is simply the data you stick in your transaction that solves the puzzle laid out by the output script. It's the hardcore cryptographic proof that says, hey, I'm allowed to spend this money.
But of course, Bitcoin's puzzles aren't some simple math problem a kid could solve. The real security, the magic of it all, comes from making that solution, the witness, absolutely 100% unforgeable.
And you can see the difference pretty clearly here. On the one hand, you've got a simple script that, yeah, anyone could solve. But on the other hand, you have a standard Bitcoin script. The puzzle here isn't about finding some easy number. No, it's about providing a valid digital signature for a very specific public key. And that is something only one person on the entire planet can do.
So, a digital signature, that is the ultimate witness. It's the solution to a cryptographic puzzle that is mathematically impossible to figure out unless you have the secret key, the private key. It's totally unique, completely unforgeable, and it's the absolute proof of ownership.
So let's just break that down one more time. The public key, that's kind of like the serial number on the lock. Everyone can see it.
The secret data? That's your private key, the thing you never, ever show to anyone. And the signature? That's the special one-time use solution you create with your secret key to prove you can open that lock. That right there is your witness. And finally, this all comes together. That witness data, your signature, it has to be packed right into the transaction itself. And you might ask, why? Well, it's so that every single computer, every node on the Bitcoin network can independently run the math, check your work, and verify for themselves that your solution to the puzzle is correct. Only then will they accept it as a valid transaction.
So the witness is the key to the whole puzzle, right? It's the solution, it's the proof, it's everything. But here's the cliffhanger. As Bitcoin grew up, developers realized there was a huge problem with where this witness data was originally being stored. A problem that caused all sorts of bugs and actually held back progress for years. And that whole story? Well, that's something we'll have to get into next time.